Scope. Scope is about where an identifier is accessible in a program. Typically, you have your global variables here, then you have your int main here, and then you have your additional functions. It's always easy to look up. Okay, um, that's global. That's why they call them global variables. Why you have local variables that are only accessible in the local area. When you're naming identifiers, be careful. If your name of a function here is, we'll just say same as your global variable, what will happen is when you use the same name, the name identifier called same, um, you're going to be using it locally here. If you want to access same up here in your function, you have to use the scope resolution operator. Okay, you can do that if for some reason you named your identifier as the same. You do need to be careful when you're using reference parameters. Okay, user-defined reference parameters using void functions in regards to global variables. Because if you recall, okay, the memory location is passed. All right, your reference parameter receives the memory location of the actual parameter. So therefore, they now share the same memory location. So any changes you make, you'll change the actual value of the global variable, which may not matter, but it may matter because by doing so, if you have an error, it will be difficult to discover what and where something went wrong. Because remember, you have more than one function here. You have multiple functions. And if those functions can change a global variable, ouch. All right, you're going to be like, well, which one did it? How am I going to be able to find where something went wrong? All right, and those are global variables that obviously aren't constants. If they're constants, then you don't need to worry about that. Function prototype. Function prototype allows you to place the function main first. In other words, we're used to seeing int main up here at top. And when C++ compiles your code, etc., it reads it from top down. And most of the time when you write your functions, programmers don't want to write their functions up here at top before int main. They prefer for it to be down below. All right, so therefore it's okay to do that as long as you use what's known as a function prototype, which is basically what you've been doing here earlier when you named and identified your function down here, but you're doing it and placing it, your prototypes, up here, which is the name of the function or function type name of the function or void function name, and then the formal parameter list. So that C++ will read it and know that it's there, allowing you to go through int main and then eventually accessing the functions down here. All right, let's look back at our reference parameter example. All right. You recognize all that. Let's look here. These are our global variables. These are our global variables. They were defined before int main. So we've got total score Slytherin, total score Gryffindor, number of regular goals Slytherin, number of regular goals Gryffindor. We have two constants, regular go 10, golden snitch 150. Here are our function prototypes. Int get Slytherin int number regular goals Sly. Same thing for Gryffindor, our print chant, and our Malfoy chant. All the prototypes are listed up here. So here are global variables before int main and our prototypes before int main, with our prototypes allowing us to list our user-defined functions beneath main. So our global variables being there, they are used here in int main. Okay, they are also used here in the void print chat function. I placed them here so that they would be entered in here and changed without using a reference variable. So to look at the code once more, we have int main cout, enter the number of goals by Slytherin, so the user enters it in. Same thing for Gryffindor, and then this little catchphrase here, total score Slytherin goes, it's our function call, goes to here, a value returning function which basically takes what the user entered, multiplies it by the regular goal, which is a global variable, which is 10, a constant global variable. And the same thing here for Gryffindor. And it goes into these two functions here, which then go in to these two global variables. All right. This time, Mr. Draco Malfoy casts his own spell and says Malfoy chant total score Slytherin, total score Gryffindor, which has just been figured and computed here. We always said 5 and 1. So this is 50 and 10. Goes all the way down to Malfoy chant here, which is a void function using reference parameters. Int and total score Sly, which means total score Sly is now a reference. Notice how Gryffindor was not. All right, so total score Sly here, 50, 10, cout, attention please, there is a Draco Malfoy interruption occurring. Malfoy casts a spell himself to defeat Potter and says, Confondo Harry Potter. Adds 100 to Slytherin's total score, which is noted here. Total score Sly plus 100 equals, or is assigned, total score Sly. We use the same variable identifier here, however, because it's a reference variable in which the memory location here and the memory location for this variable are now for this variable are now the same. So therefore total score Slytherin is now 150 because we added 100 to the previous 50. Notice the next call function here. Print chant total score Slytherin, total score Gryffindor, 150 to 10 to print chat or print chant, void print chant. So here's our user defined void with value parameters. Okay, total score Sly is now 150 because all that happens with value parameters is that the values are passed from the actual to formal parameters. Here's our actual parameters. Here's our formal parameters. So 150 and 10, I went ahead and just made it, assigned it to the global variables. And I did that before I did this reference parameter example, since this is kind of needless, so to say, at least for Slytherin it is. Int count equals 0, while total score Gryffindor is less than total score Slytherin. Total score Gryffindor is increased by total score Gryffindor plus our regular go, which is 10 points. We need to count the number of times that happens and increase Gryffindor. And then total score Gryffindor, once it's caught up, in other words, once total score Gryffindor and total score Slytherin are now both at 150, Gryffindor gets the golden snitch, which increases them by 150. That makes it 300 Gryffindor, 150 Slytherin. And then here we have our nested for loop, if you recall that. That's why we did the count here. That's with Harry saying aguamente. And in this case, a lot more times because Malfoy did his chant. All right, and then we said final score Slytherin is total score Slytherin, total score Gryffindor, etc. So let's go ahead and run this one more time just to look at it. So let's run it. 5 and 1. So he knows down 40 points. If Gryffindor is behind, Harry ends the game with the following chant. Before he can even get to the chant, Draco Malfoy enters in his user-defined void function using reference parameters. Okay, so thus he does his spell, Confondo Harry Potter, adds 100 points to Slytherin's total score. Now Harry Potter has to come from 10 points to 150 points plus ending the game. So this Aguamente spell is to get him to 150 points, and then of course he catches the golden snitch, bringing him in Gryffindor to 300 points from 150 points, which is where Slytherin is at. And now Harry's voice almost gave out. Function overloading. Function overloading just simply allows you to use or create functions with the same name. However, they have a different formal parameter list. All right, let's look at a definition here. Signature. A signature consists of the function name and its formal parameter list. All right, the function name and its formal parameter list. That's what a signature is. A call to the formal parameter list determines which function will be used. So even though you're calling the same name, all right, how you list your formal parameter list will determine which function is used. And you can have function overloading when you have the same name for a function, but what's different is that you have different formal parameters. That's function overloading, and that's just an intro to it. We'll get into greater detail about function overloading at a different time. So here today we talked about functions, and the reason to have functions again is not to have a bunch of stuff in int main. We want to break it out so that multiple people can work on it at the same time and get our stuff done quickly. We begun by talking about predefined functions, is what we've been working with before, to user-defined functions where we can have either value returning or void functions. All right. With void, we cannot return something unless we use reference parameters, in which case we need to be careful because memory locations are shared with one another, and that's how data is actually being so-called passed out of the function. And when that happens, when we talked about scope, we need to be careful with our global variables when that happens, because we can have problems here. Be careful. Because we don't want to write all our functions above main up here, we want to write them after main because it just looks better and it works for us that way. we use function prototypes. And of course, if you want to write functions with the same name, we can by using a process called function overloading, in which we'll get into detail at a later time. That's functions.